Good evening. Hope everyone's having a good conference so far. All right. Very good. Very good. So tonight is Grill the Committee. This is your opportunity to ask questions of the people who are defining the architectural language of the language we use. What? Can you guys work on that? There's some kind of echo. Can you maybe take me down a little bit? My wife can help you with that because she's been trying to take me down a lot. Anyway. So this turns out to not be the entire committee. I'm not certain we could put the entire committee on this stage, but we have a few individuals who are going to have to bear the brunt of the grilling for this evening. I want to talk about why the particular individuals that are here. So we have the Titus winners is the incoming, I just asked him this a second ago, get the correct title. The incoming library working group chair. Evolution. Library evolution. All right, so I managed to screw that one up. Let's see if I can screw it up for Ville too. Okay, he pointed out, I referred to it as core evolution. Of course, they don't call it core evolution, they just call it evolution. So he is the chair of the evolution working group. Is that right? Okay. So other than these two and Herb, who is the convener of the committee, everyone here is here because of a particular feature that they've been associated with championing. So the first question I'm going to ask you is to introduce yourself and talk about what that feature is, what its status is, how far along is it, where are we at, and I think I hope most people know the details. I don't think we have to go into that, but just tell us a little bit about what the feature is about.
My name is Andrew Sutton. I am the project editor, formerly the project editor for the concepts technical specification. I helped bring concepts into C++20, half of it anyways. An important subset got added to C++. We are still trying to work out the remainder of it, but hopefully that'll happen by C++20 also.
So the status is it's voted. It's voted in the working draft for 20.
Yes, the working draft has been voted into C++20.
Okay.
Although the working draft lost half of its weight in Toronto.
Well, trust me, losing weight is not an easy. Okay. You can pass. I've already introduced you, Titus. There we go.
My name is Louis. I represent Amazon on the C++ committee. I'm also a member of the Canadian delegation, and I work mostly on language level support for metaprogramming. So making template metaprogramming nicer. I also do some tweaks to make lambdas better, like template lambdas and stuff like that.
So my name is Eric Niebler. I work for Facebook. I am the prime mover of the ranges technical specification and former project editor. The ranges technical specification was sent off for publication at the last committee meeting. Super excited about that, which means that I can stop having to process bug reports on the ranges technical specification. And other than that, the ranges work is based on my range v3 library. The ranges technical specification is only a small subset of it, so I still have plenty of work left to do.
Okay, I'm Gabriel Reis. I work for Microsoft on the C++ team. Currently, I'm the project editor for the modules technical specification. At the last owners meeting in Toronto, it was sent out as a PDTS ballot. PDTS means proposed draft technical specification. It's still on the ballot, and I hope that by Albuquerque meeting, which is in November, we'll get all the votes in, and hopefully we'll move on to the next stage, which is we move to a publication, assuming things work out properly. Modules, from my perspective, They allow you to organize code at large scale, not at small scale. Small scale, you have classes and namespaces to organize your code. But we're talking about when you have large organizations, large code base, and you want to put some structure there. The goals are componentization, better software architecture, isolation, to allow better build throughputs, and semantics-aware software development tools. Those, I believe, are very important. We need to think more about the tools that will help us to be more productive, and that requires of us to be more picky about how we practice, how we write programs. Code hygiene is very important. The techniques that we've learned, used in the past 30 or 40 years, will need to take a hard look at them. I'm looking at you, macros. I know it is a controversial issue, but I would like to encourage the entire C++ community to think hard about how we write code.
Okay, I'm Bjarne. I try. I try to think about the whole language, including the library, and where we're going over the next few years. I was sitting here and thinking that the group in this room is roughly the size of the active members of the committee. Not everybody turns up at every meeting, but this is the influential size of the group. So how do you make a consensus for doing something new and interesting and forward-looking in a group this large, where everybody has some old stuff they would like to protect? That, I think, is the fundamental problem. Having a group like this agree and have a consensus is very, very hard. I'm in favor of some proposals, usually proposals I have worked on for 5, 10, 20 years. I would like to see concepts, all of concepts, not just the backward-looking bits. I would like to see simple static reflection, very simple functional stuff, nothing fancy. I would like to see modules, and as Gabby said, modules that really promote hygiene, so we're not stuck back in the mid-70s with your macros infecting my code and my type defs changing the meaning of your code. These are hard things. I would like to see the range proposal, including the good bits that they haven't dared put in yet. I try to look out for the whole language. It's hard briefly to talk about the whole language, but let's move forward. The community as a whole lives among other communities, and there are strengths that we have and there's strengths that they have, and we can't just rest on our laurels and assume the world isn't changing, because it is, and we have to face new challenges.
Hi, my name is Nishanov. I work for Microsoft. My official title in ISO committee is the project editor of coroutine TS that was sent for publication from Toronto. Coroutine TS, I think, completes your mission of bringing stuff from Simula to C++, because it's one of the features that was there. And I think I know what you were going to say, and I will say it.
You don't.
Okay, go ahead.
No, I was just going to apologize for not mentioning coroutines, and especially fast coroutines, because they hadn't been mentioned this far. Sorry.
Oh, I was going to mention that actually C++ had coroutines, or more precisely, there was an AT&T task library which funded C++ development, and it was by Bjarne, and you can download the AT&T task library, at least the documentation. I found it on the web. It's awesome.
It's stored under history.
So coroutine TS comes naked. It's purely naked facility for expert developers. But before C++ 20 ships, we will have great library types which make coroutines use easy. And we will have beautiful interactions with ranges. And I think Eric was exploring recently and had some fun. And plus, we have networking, and all of those beautiful things will tie together. And yeah, that's it.
I'm Herb. Herb Sutter. I do a lot of administrative things in running the committee and herding cats, although people like Ville and Titus help a lot with that. They pre-Titus as Jeffrey, or Titus is the post-Jeffrey. We're sort of in that middle phase right now. But I also have worked on a number of C++ proposals, null pointer, lambda syntax, enum class, a lot of those things you can blame on me or delegating constructors or partly on me. And right now, I'm mostly interested in, and I dearly hope in my technical contribution to be able to, I hope, spend the next decade or so on making C++ code simpler, even as we evolve the language, which can only be done compatibly by adding to it. And I think it is possible to add to the language, to evolve it, because it is a living language that is widely used, will continue to be used, and needs to continue evolving, but also make C++ code dramatically simpler. So I think that's possible, and I hope to continue working on that. Some of those effects are in a research stage right now, and I'll talk about some of them on Wednesday. But I think that will be essential for the future of C++, and I'd like to contribute a bit toward that.
All right, thank you guys. All right, so the format this evening is for you guys to come down and ask questions. And I'm going to ask them a few questions kind of while you guys think about the questions you want to ask. I'll tell you this, we'll probably be pushed for time at the end, so if you think of your question, you want to get down here quick. All right, so the first thing I want to ask is, you guys particularly, because you're all associated with something you were pushing for, but in the committee, you could almost think of it as you wear two hats. You wear a hat where you're trying to push a particular proposal, and you wear a hat where you're trying to push back on proposals, right? Because that's the game, right? So I want to ask you to think about a situation, and you don't all have to come up with this, but if we had some interesting stories, that's what we're going for tonight, where you got pushback that you at first thought was kind of ridiculous. It's like, okay, I'll think about how to deal with that, and then realized, oh wow, this proposal has really benefited because of something that I hadn't thought through well. And at first, wasn't an oh wow, brilliant. No, at first it was like, oh. But then you said, no. Now I realize what's going on, and it's better. Anybody want to fess up to that? Microphone.
Yeah. So the ranges TS was born out of some early work that I had done on ranges, and I floated it on the ranges discussion list. There was a working group, and I thought my ideas were terrific, and everybody should listen to me. And then this guy named Sean Parent came along on the list and corrected me that my ideas were not, in fact, all that great, and he had some better ideas. So I was extremely resistant, and so was Sean, and he's a remarkably difficult person to convince. And so in the end, I ended up changing my proposal, and I would be generous to myself and say we met somewhere in the middle, and I think the proposal is infinitely better for Sean's feedback, despite the fact that initially I really didn't think very much of his ideas.
Thank you. Anyone else want to share? Yeah.
From my perspective, I think it's the wrong question.
Okay.
Because
I'm willing to be corrected as well.
My ideal way of having a proposal develop is that you articulate a problem, and then you articulate sort of a first idea of how to solve that problem. And then you discuss in committee and outside ways of approaching this, and discuss how you would like use cases to be worked out, and what would look like good code once you have it. And once that discussion is going on, sort of a proposal firms up with more precise syntax, more work on edge cases, and refinement. And I find that one of the problems with the current committee is that people want finished proposals prepared, put forward with exact semantics, exact syntax, and endless precise wording. And we end up talking about technical details rather than what I consider fundamental language design problems, which is basically what's the problem and what's the fundamental way of dealing with it. And we spend endless time discussing of technical details before we have agreed if and what the problem is.
So do you believe that in general the proposals that are coming to the committee are trying too hard to have a full solution and might be better proposals if they worked more on just, defining use cases, defining edge cases, and then giving much less thought to what the wording should be and that kind of thing?
I think so, yes. I think that the committee should be more collaborative in developing solutions. I think that people come in with a proposal and they defend it, as opposed to bring a proposal and see how it works out and then jointly work towards a solution. I think there are too much defensiveness, too many demands of perfection before the time.
Okay. Yeah.
I think I have a pretty decent follow-up to this. During C++ OX standardization, there was this idea of having a no except auto facility. We didn't get consensus on it at the time. I brought it back early in the C++ 14 standardization phase. And then Bjarne asked, who's this for and where do you need it? My response from a library vendor perspective was that, let me count. I need it in 5 places. He asked, do you really need it? I said, no. He asked, is it going to be a maintenance burden for you either way? I said, no. So his follow-up was, what are you going to do next? And I said, I am going to bury this paper and not advance it.
All right, Izzy, you have a question for us?
All right, so I've actually got a few, but I'll make them quick. So 2 years ago, I stood on that side of the room and said to the committee, when are we getting the restrict qualifier? And I was told it's coming, and it's been 2 years, and it's still not here. So where is it? And then
I think because there's a queue, you should get one question each. So
Okay.
to answer that one, I talked to your colleague just before we started, and he said he was going to have a proposal for the restrict qualifier.
Okay.
So I assume it's coming from there. The only advice I gave him was, please, cleaning it up a little bit and toning it down, don't make it just C99 restrict, because that's not enough. And he said, oh no, of course not, which is 1+ sign.
Okay.
It seems as if the authors of that proposal have been busy with other things. But you can find those authors. Their names are on that paper.
No alias must go. This is non-negotiable. This was Dennis Ritchie's answer to the father of restrict. Restrict has come up repeatedly, And the reason it has failed is that it doesn't fit in the type system. It means trust me. It's a form of cast. And we have repeatedly decided that this is a very useful cast in restricted environments where you can sort of trust this cast. But we don't like trust me in the type system. And therefore, any proposal that proposes restrict is going to have an uphill battle. Because some of us has kept seeing it for almost 30 years, since Dennis Ritchie came out stronger against it than I would ever do. And we'll ask, how does it fit in the type system? How does it generalize? How does it interact with types higher than raw pointers? And why should this be a core language feature rather than a specialized high-performance computing feature? This is a firm prediction because I've seen it happen repeatedly.
Okay, thank you.
Is that Odin?
Yeah. Hi, I'm Odin. I work in bare metal embedded, but I have a very different question. This is probably most for Herb and Louis, but I've seen problems with debuggability of a lot of code generators because they're very common in my field, and also in D, the mix-ins are pretty impossible to debug, and people already complain about stepping through my TMP. Isn't this a problem for metaclasses and such, that people are stepping through code that they did not write?
So I think you basically outlined the, you already said that it was a problem right now with TMP, right?
Yeah.
Is anything worse than TMP? If you ask me, I mean, I like TMP, but most people don't. And so what I think is there's an interesting quality of implementation challenge for compilers to give us a way to, debug the metaprograms that we're going to write. But I think that if we're not abusing the type system the way we are today, they can actually provide us with better ways of debugging our metaprograms. So there's nothing worse than the status quo.
The question is more to the user who said, interface or whatever, loaded keyword or overloaded keyword you're using, and writes a class that looks like the way he thinks about the problem, and then steps through and sees this terrible template monster that he does not understand.
So you mean stepping at runtime?
Yeah, at runtime. Somebody who's writing hello world and then steps into.
Mm-hmm.
Yeah.
So again, I would say this is a quality of implementation. Like your debugger should be free to basically jump through these things without showing them to you unless you maybe request it, right?
So I'll answer in more detail in my talk on Wednesday.
Okay.
Because this is one of the questions about any code generation style approach. The short answer, spoiler alert, is what Louis said, but I'll expand on it a little bit. The first is, look at what it's replacing. No, seriously. So one of the taglines that I thought I came up with, and then I saw Louis in his Meeting C++ keynote last winter use the same tagline, and I don't know if it's because we ever talked about it or just came up with it independently, is we both want, and I assume you're still there, we both want more metaprogramming, less template metaprogramming. We're doing it already. We should have a clearer way to write what we're writing already, and it will be strictly better than what we are already doing that is undebuggable and inscrutable today. The second argument is, especially with code generation, we are already doing that too. We generate special member functions. When's the last time you tried to step into a compiler-generated copy constructor and nothing happened? that problem needs to be solved already for the special member functions. Yes, if you provide people a way to generate more of those programmatically, yes, but it's a degree, not in a kind of a new problem. And anything that implementations already do well for the special member functions will directly help the other generated functions and vice versa. In both cases, I think the key thing is, as long as we focus on trying to improve the things people are already doing with C++, but with great difficulty, we're on the right path. And we're certainly not making things worse. Longer answer to follow, but that's the bare bones of the idea.
My suspicion is that before any of this actually gets approved, or shortly after it gets approved, there's going to be, by necessity, a ton of work in tooling. Because as sort of library lead for a large code base, code review is sort of important. And if you've hidden away any significant amount of stuff in metaclasses, I'm going to need a way to toggle between views in code review, in browsing, in everything. And at the point that you've built that, like, it's not that much harder to rig that into your debugger. I mean, there's work there, clearly. But, like, we have to solve these UI problems for many reasons. And the end result is going to be well worth it.
I think it's a very important question that you brought up. Anything we do at compile time, which means it evaporates when the code is running, poses challenge. So Herb points out correctly, special member functions that are generated by a compiler that we do not see. However, when you go further than just these special member functions, where you actually generate code or class or the kind of thing, it poses real challenges to tools. And if the tools are not there, you're going to have a very miserable reputation for the facility. I distinctly remember when I started writing templates back in 94, 95. It's just miserable. The part that worries me is when we say, oh, we know about this problem, we have this problem before, and then it is no worse. And I will say, oh, actually, it is worse by adding more. So epsilon is epsilon, but n times epsilon becomes very noticeable for a big number of n. So I'll be very cautious and not holding to, oh, we already know this problem, so it's not making it worse. No, we are adding to it, so we must be very, very cautious about that. My friend here, Ville, has written Lisp compilers and has some experience in that department. I've written Lisp myself, and Lisp is this language where everything you have at runtime, you can lift it to compile time, and with eval when operator, where you can specify, oh, is it compile time, is it load time, is it execution time? So you actually have fine-grained ways of doing this. I don't know that the full power of that is actually used in practice. So there we have opportunity to learn as language designers what is actually really important, right? So, we definitely need static reflection. That, I think, has to come, right? When we go further, we have to study how much of that is actually useful, important, that we need to have in the language. And then we need to bring the tool builders, compiler writers, not just compiler writers, source code browsing, things you need to do at review time, at design time, before you even write the code for review. It is non-trivial challenge. It is not, oh, we already know what it is. It's really non-trivial. I guess the last thing I would like to say is I really am a big proponent of compile time. Computation. I was fed up with people writing functions with class specializations. Back in '98, how we used to write metaprograms, you have to write a class and then specializations, all that. So with Bjarne, we introduced const expert functions, which is just go back to what has been very successful, understood by all programmers. It is just simple function. Now, ensure that you have the right condition that the compiler can evaluate those functions at compile time. And it is the same structure that programmers understand very well, right? Runtime functions. And we also made sure that you don't actually have that much distinction between what is being evaluated at compile time, what is being evaluated at runtime, so that if needed, you can actually place sufficiently small conditions to have this function run at runtime so you can put debugger there and see what is going on. It is exactly the same experience that you have with normal function. And that's some form of engineering, right? It's not a perfect, we don't have the full power of compile time computation, but it is the balance between the full abstract power of language design and what is actually practically necessary and useful.
C++ has an awful reputation for being write-only, incomprehensible, too complex, expert-only. And there are some major factors for giving this. Template metaprogramming is one of them. The more advanced parts of Boost is another one. I don't know if I have any friends left in the room, but this is a fact. And some of us has been working for years on the theme of simplifying C++ as used by most users. Make simple things simple and make sure that you can do the advanced stuff if you have to. One of the things that got me with template metaprogramming was people writing templates, defining types to calculate values. If I want to compute the value sort of 2 or 10, I want to call a function. We got const-expr functions. It cost a lot of blood and sweat and tears, mostly Gabby's. And the committee was very conservative. It was deemed useless, impossible to implement, and a few other things like that. But I think it takes away half of the complexity of template programming, which was a template mechanism being used for things it wasn't meant to be used for, and it wasn't good for. Another aspect is that we are having templates with compile time doc typing. From every other place in the language, we know that precisely specified interfaces is a great savior for specifying things correctly, for catching errors early, from avoiding to write errors in the first place, because we don't have to write against totally arbitrary things. And my guess is that concepts properly done will take away another half of the problem. Now, finally, we come back to the metaprogramming that we were talking about. And I think we need some fairly simple template metaprogramming. We want to be able to walk through a data structure and generate object maps for it, to generate serializers for it, and things like that. And in particular, I want to make sure that if you do the object maps for X, and I do the serializers for X, our programs can compose. And if that's not the case, we have a dialect generator. One of the great advantages of C++ is there aren't too many dialects. Lisp is more beautiful in some sense, and more flexible in some sense, and has an implied plural. You can't collaborate with other people in a language where everybody has their own dialect. And so I think we have to keep improving the language, both in terms of what we can do with it, and especially in how easy we can do writing, using, and debugging the stuff. I have a colleague in Budapest who has written a really nice debugger for template metaprogramming. The complexity is beyond belief. Nobody should have to learn that. And so we need to think about the representation of C++. We need to think about how simply we can do simple things. Really, if I want stream IO of X, I should say stream IO open paren X close paren. That's all I want to say. And you should be able to write the code for it. That's basically a simple for loop over the elements of a structure. We have 3 proposals for how to do that. Last time I counted, probably 5, and if you look at the details. We need to pick one. And the way we do that, if we do it right, in my opinion, is we pick the important use cases. There is about 4 to 6. No more. We do those, we do them well, and then we see what happens. What more do we need? Let's not build or try to build the perfect, fully general metaprogramming system. For starters, that has never worked very well. Getting the simple cases working simply and well and with low compile time overheads, that kind of strategy has worked over the years, and if we don't get it quite right, we have a chance of fixing it. If we instead spend twice as long, we have nothing to gain experience from, and there's so much that we won't be able to fix it once we get it wrong, which we sure will. Simple or complex, but we're getting it more wrong with the complex, more complete version. So my suggestion is work on simplification, which is good concepts, good const per functions, and then good generator functions, basically based on the idea of iterating over a type and doing appropriate things for it. And let's start small and grow it.
So couldn't agree more. And something, just a hopefully quick comment following on something you said. To keep simple things simple. So easy to say. Everybody and their kid, brother, and their dog gives lip service to that. And they don't do it. Why? There's at least 3 major ways to go wrong. First is not to try. Not to be aware of keep simple things simple. Another way to go wrong is to try to make complex things simple. I have seen many proposals in committee for that. We have this nice syntax for this case. Well, is that the majority? Is that the common case? Well, no, but it's the case I like this today. No, we shouldn't waste the good syntax on a complex thing. So there's actually an art to keep making simple things simple. A third way to go wrong is to make them simple to write but not to maintain, which is exactly what we were talking about and what you were talking about with how do I debug the code? How do I know what it does? How do I do my code reviews on it? So the process, like everything I'm going to talk about, except reporting other people's work, which is more advanced on Wednesday, is pure experimentation. We're trying to solve a problem. We're still defining the problem. Things are going to be mutable. But here's a direction worth exploring. Maybe it'll work out, maybe it won't. But to do the things that Bjarne said, aim at keeping simple things simple, make sure you're focusing on the actual simple things and not just to write, but to maintain, and being example-driven. What are the use cases? What are the things we want to say, and how do we want to say them simply? If we keep that mindset in mind, it will help make all our proposals so much better.
And I would like it for 20.
Wait, like what for 20?
The simple version of this, basically my loop over
the C++11 const expr version. As in a very small feature, yeah.
Yeah, the reflection thing, I hope to get all of concepts, and const expr is almost there. But basically, I hope all of this will be available soon, like in 20, meaning we have to get things running and tested out over the next 2 years. I don't want to go for the super general perfection in 2030 or some other scary thing like that.
Yeah, so I'll try to make this really quick. Sorry for all you people who've been getting tired waiting. About the debugability of template metaprogramming and metaclasses in particular, I've had the same criticism leveled at my ranges work about range pipelines and the debuggability thereof. And I think it's far more general than ranges or template metaprogramming. It's really about abstraction. And if you are used to operating at a certain level of abstraction and someone comes along with a higher level abstraction, a better abstraction, it's natural to feel resistance because I'm not used to operating at that level of abstraction. That's not how I think about things. I don't know how to debug that. I can't reason about that. Or I'm going to have to compile it in my head down to the lower level code just to understand what's going on. But we do that all the time. We don't think about how virtual functions are implemented, right? Well, some people do. Okay. Right? The important thing to ask about an abstraction is it a good abstraction? Can I write more code more efficiently with fewer bugs with this abstraction? And then can I learn to think in terms of that abstraction instead of the lower level details? And then maybe you find you're actually spending less time debugging because you're writing fewer bugs.
I will strongly agree with you, but I think Bjarne's points are also good. Everything you said, but the abstractions have to be usable, not just write-only, so we have to make sure of that. And for them to make sense in this language, they had better hew to C++'s pillar of zero overhead abstraction. Zero overhead principle, machine near, I can always open the hood and take control. As long as you do those things, then it's C++. Otherwise, we're just proposing a feature that belongs in some other language.
All right, thank you. Nicole.
Sat down.
Yeah.
It was a long discussion.
He was there. He was the line before me.
Okay. So first of all, I'd like to talk a little bit about restrict, and then I'll get to my actual question, which is like the whole no alias thing. That feels like that thing where you're making the complex case simple at the expense of the simple case, which is, I just have 2 pointers that I don't want to alias, and their parameters, and I don't care about all this stuff. I just want them to not alias, which is why I like restrict, and why C restrict is terrible. Yeah, and so the question that I actually had was about non-type template parameters. First of all, that's the worst name ever. It should just be called value parameters, because you also have template parameters, which are also not types, but they're not non-type template parameters. So I'm going to call them value parameters. I would really love value parameters, value template parameters of non-integer or integral type. I would love literal type template value parameters. When can I have that?
Well, we designed them, and you should just ask for them louder, because some of us really can't tell the difference between a user-defined type and a built-in type.
Right? That's what I'm saying.
Yeah. So, and actually, there have been several suggestions in that area, and notably by me. I think there is a paper somewhere that proves that something was impossible. I didn't have time to go through, but usually when someone goes and proves that something is impossible to me, let's just say politely that I lose trust. So it is one of those things we want to have. Right now we have a lot of high-level stuff that we need to get through, like modules, coroutines, static reflections, and networking. But at some point, to make simple things simple, this is one of those places where, because everywhere else, we don't see a distinction between int and complex of double, except the semantics. But from type perspective, basically the same thing. And you should be able to use a template that way. We made some progress there, but yeah, that's coming.
I think you have to demonstrate that there are some real use cases, and it should be on my top 20 list of features, because I think it's obviously right, but is it important enough to spend the time on it?
Mm. So about when you can have it, first you need to solve a bunch of obstacles. You want to have a non-type template parameter of a user-defined type So the question becomes whether you want that type to have a user-defined equality operator, and where is that operator defined, and how do you avoid ODR problems? These are the things keeping that facility sort of back. We haven't been able to find reasonable answers to those questions.
Well, I think Louis has
Can I add something? It is not that we haven't found reasonable answers to those. It is that we as a committee have not been able to agree on a solution, which is very different.
If we agreed that the problem needed to be solved, we would solve the technical problems.
Yeah.
The technical problems are not the hardest.
Well, this one is kind of hard, but I think there is a solution, especially if we get compiler-generated comparison operators. We could say that basically any type that is constexpr friendly and has default, compiler-generated equality operators, we're kind of able to link them. And is Jeff Snyder in the room? And so, how's that proposal going? No pressure. Albuquerque? Okay, so we've got some, it's baking.
This might be a good example also of what Bjarne cautioned against and Gabby cautioned against, of jumping to a solution. So start with you. I would love to start with the use cases. What are the things we're trying to do, and then we can evaluate how common they are and so forth. I have seen at least a few examples of people who wanted such a feature, a general way to have non-type template parameters. On a template, sorry, just pulling the chain there.
It's a bad name. You can use it.
For the purpose of computing something, because they want to use it for template metaprogramming. Give them something completely different, such as an actual compile time function. They might find that that expresses what they want even more directly, and the use case goes away and is better solved by a completely different approach. And that's why it's so important to start with the use cases, the problem to be solved. How common is it? What's the code I want to write ideally? And think outside the box and brainstorm early on before narrowing in on one particular solution. Because maybe in this case, you actually don't want that feature. Maybe what you really want is compile time functions, and Louis and friends will help you get those. I just signed you up for work, by the way.
I know. So I do think, though, that even if we get proper compile time programming, there is a use case for that. I don't want to get too technical, but the problem is that when you pass a constexpr object to a function, from within the function, you've lost the fact that it is a constant expression, because it's just an argument. You don't know whether, so we don't have constexpr function parameters, basically. That's kind of the problem that this is solving. And so even if we get like super fancy, standard vector, standard string, and constant expressions, which we're working on, we still don't have a way to propagate this constant expressionness through a function called boundary. And so this is exactly what this gives us.
And the important thing with that is that you can have the return type depend on the, I want simplified dependent types in C++, and I only really get that when I have integral types.
So personally, I think it's a valuable feature. There are some technical challenges to be faced, but we're kind of working on that, and we'll see what the committee thinks about that.
Clearly, this is not my evening to make lots of friends by making promises. What is the use case? The answer that I can write more elegant template metaprogramming is not an answer I'll accept. It is, what can I do with the template metaprogramming that helps users solve real problems using that? You have to go one step further. And maybe you have it, but I haven't heard it yet.
Rust-style format strings are what I want. It's like compile time checked format strings.
Now we're getting real.
Say that again? Sorry, I didn't hear that.
Now we're getting real.
Yeah, that is what I want. I want like a string view template parameter.
There are other ways to do that.
So what I'm doing is
I'm not going to talk about it. but there are other ways to do it.
So decal type lambda expressions work because you can create a struct or a class inside a lambda expression. And then you can decal type the return type of that lambda. And so you create an anonymous struct type that has an operator, open paren, close paren, that returns the value of the string as a const expr.
How many years of computer science does it take to get that right?
A lot.
Not much computer science, but
This
lots
is
of
known
programming.
as a problem.
Yeah.
I mean, you see why I'm pushing back for use cases that a majority of users can use. Before I push it up in my top 20 of things where we should spend a lot of effort on.
Yeah.
You have some work to do there. I'm not hostile. I understand what you're saying. I understand the type algebra. I'm pretty sure I know how to implement it, but that's not the problem.
What he said, I love the compile time format strings. Kudos. Run with that. The rest of it sounds like one of the pitfalls I just described a few minutes ago from make simple things simple. One of the ways to go wrong was to try to make complicated things simple. I worry this might be that.
Also, a lot of the thoughts on format strings are informed from C format strings, like, var args things, where it was necessary to have a user-specified description of what type it was. This is a language about types. The compiler already knows all of those things. We have there's clearly room for better technology here. We should not be trying to mimic the 70s style design. We should just do something better. There's things in the works all over the place.
All right, so let's take a question from this side.
Hi. So I have a drastically different question. When you have a large project that you're trying to propose to the committee, something on the scale of years, modules, concepts, all these other things, how do you maintain momentum through all these years and actually make the project a reality in the standard?
First, you try not to lose it, which is very difficult. You keep making the cases, right? So we talked earlier about the use cases, if they're compelling that we have had with concepts. We explained what the problems were, everybody's running into them. It's really important for the community to get something like that into the language. For modules, you get similar problems, right? Everybody's suffering from lack of code hygiene and macros getting into your system. You don't have a good sense of what your template codes mean when you ship them. Build time. Most of our code these days are leaving the headers, right? Which is a problem. So you get to explain this to the community what the problem is. First, define the problem, and then patiently work through the possible solutions, and eventually try to convert to a place where we say, let's try this to see if we have a good solution for this set of problems that we have. But I guess the most important thing is try not to lose it. I don't know, but Bjarne?
I didn't hear everything because I was thinking of something else. So if I repeat you, apologies. What I was thinking about was sort of practically what can keep me working on a problem for 20 years, which is definitely related. And I think, first of all, it's individual. What applies to me may or may not apply to others. What applies to others sometimes applies to me, but not always. I've seen people motivated in different ways. None of the motivation comes from the Standards Committee. The Standards Committee feels like a huge barrier from getting your great ideas that will solve all the problems out into the real world. And in that, it does a rather important service. because your ideas aren't as great as you thought they were. What keeps me going is the applications. And I see people doing really important, interesting stuff that I like. I mean, it may be a space probe, it may be the brakes on your car, that if you screw up, you die. It may be large distributed systems, network systems, and such. And I look at those problems and I think, wow, this is important. People's lives and livelihoods depend on it. And boy, it's pug ugly. We can do it better. And so I look at problems starting from what are people doing out in the real world, meaning things and people and such, not inside it. And then I look at the code about how they do it, and I wonder, how could it be done easier? How could it be done more economically? How could it be done faster if speed matters? How could it be done more reliably if reliability matters? And these things often matter. And from there, I go to what are a set of sort of candidate improvements. It could be a library, it could be a language feature, it could be something that could be standardized, or it could be specialized. But I keep coming back to what does this actually do for people out there in the non-computing world? And I keep thinking that whenever I find the solution, computer science is a really powerful tool. We know how to do most things if we decide to do them. I can read the academic papers, I can see the experiments with other languages, I can see the libraries used. I don't worry too much about whether I can do it. I worry about whether I have the right problem. And once I decide that I have the right problem, it hurts people when it's not there. And then I start working on a right solution. I try to talk to people who know more about it than me. I try to talk to people that can help come up with a solution. Sometimes I compromise too much, sometimes I compromise too little, but we have to find a solution that helps. And that's what keeps me going. Arguing about a particular where to stick a comma can keep me excited for at least a week. Because, well, that's the inner geek, right? We can argue about those things for at least a week. But it doesn't keep me going for years. For that, you need some really fundamental problem that can make a fundamental difference. Currently, the ones we're looking at are concepts, some concurrency parallel things, some composition of library things, the modularity to clean up your code, and the static reflection things that allows us to compensate from the problems of not having other forms of reflection. And these things have been keeping me going for a longish time. Concepts definitely since the late 80s. So if I'm impatient, that's one reason.
Okay.
So I started my range library 4 years ago as a weekend hack. And what's kept me going is that, well, two things really, one external and one internal. The external thing is the feedback that I've gotten from its users. And it's been overwhelmingly positive. What keeps me going is that every once in a while I actually get a piece of fan mail. Someone says, like, dude, your range library helped me do X, Y, or Z, and it's really terrific. You know, coming to conferences like this and meeting people who know my stuff and use my stuff and have encouraged me over the past 4 years to continue with the standardization of the library. And then the other thing that keeps me going is more internal. It's you know, I might you know, surf around Facebook's code base and think to myself, oh my God, or I would look at code on GitHub or people's solutions to problems, and I think there's just too much complexity in software. And so what motivates me is my intense need to hack at the root of software complexity. I can't not do something about it.
We have the project editors of two of the long-running projects you've talked about, coroutines and concepts on stage. I'd love to hear from Gore and or Andrew.
Pain avoidance. Yes, so people are most motivated when they're trying to address the personal pain. Before joining C++ team, I was writing async code for 15 years in the OS division, so it's a big personal pain to write async code, so I kind of want to help.
So you consider the process of standardizing coroutines a lesser pain than not having them?
Possibly joining C++ team was the pain avoidance.
Anthony, or Andrew.
Thank you.
So having worked on concepts for 6 years, 7 years, it always helps keep you focused when you feel like you're working on something that's going to improve somebody else's job or life later on. That's certainly one thing that helps keep you going on a project. Positive feedback from users is great. Bug reports, maybe less so, although they are a good measure of users. So if you actually get bug reports, that means you have users and therefore your work is at some level visible. These things also kind of help you keep going. But Gabby's actually pretty right on this. Try not to go insane. Was that what you said? Yeah, especially through committee. It can be a soul-grinding task to push a large language feature through the standards committee. And you will lose sleep over it. Okay, bye. Thank you.
All right, so I want to thank you very much, guys. I want to take a question from Izzy, but we are now going to introduce the new 2+2 rule. We're going to have 2 people respond with no more than 2 sentences. So think about your responses very carefully. Izzy, what's your question?
Okay, well that sucks because I was going to ask Gabby about modules. So, so I've been looking at them extensively, and one of the things I've noticed is that with the current way that both Clang and Visual Studio handle them, is that if I have a module B and module A, and A imports B, and I try to compile module A first, and B hasn't been built, the compiler errors out because the module interface isn't there. How is this solved without turning the compiler into a build system? Two sentences. Yes.
2 sentences is ridiculous.
A lot of commas in this sentence.
Make it a run-on sentence.
Yeah.
Deep breath.
Yes. So this is a problem for tool vendors. It is not a problem in the language specification. So I am also a tool vendor, and the way we're going to solve this is also to get your build system be module aware. Okay. So that you actually have a complement, not you don't bring the builds into the compiler.
Okay, thank you.
And it's such a friendly operation. Sorry? Jorg.
Yeah, so my real question is what exactly determines what can be added to the language and not? And I'll cite what I see as 2 conflicting examples. So back in the 90s, there was a proposal to add the keyword inherited to the language. So you could call your superclasses implementation of a function from a subclasses implementation. And the answer was, this doesn't provide something new. You can just simply type def your superclass to be inherited all the way down, and you've already got the feature, so why do we need the compiler to do it? More recently, I would say the counterexample is we introduced the keywords and, or, not. And those seem definitely something that the language could already do. If nothing else, you can just use #define to do it. So just trying to get a better feel for what makes it and what doesn't.
2 sentences is not enough to answer this question.
That's one.
Navigating large class hierarchies is not at the top of my priority list.
I could be wrong, but weren't the and or not aliases already in C? I thought they were at least in the C++ preprocessor since before the inherited keyword, but I could be wrong on my history. They've been there a long time.
They are macros in C and they are keywords in C98.
All right, I think we want to come back over here.
I'll try to format this for brevity. Should C++ have an explicit way of declaring an uninitialized variable so that we can get rid of doing it any other way?
No.
Thank you.
You should initialize your variables.
Thank you.
No follow-up.
Go ahead.
Oh, wait. Maybe. Think about our paper.
Oh, leave us hanging. What a second sentence.
That was 2. You can talk about it later.
Okay. All right.
Speaking about real-world use cases, there is one use case which everybody in this room uses regularly, and the way it's currently implemented in C++, at least 80% hate. I'm speaking about formatting in Iostream using overloaded chevrons, overloaded shift operator. The question is how sacred this concept is for the committee, and do we have a chance to have something more usable and more readable than overloaded shift operators for formatting? In other words, after those 30 years when each and every book on C++ uses cout shift operator something, can we finally have something more usable and readable for real world?
My compiler people and my optimizer people and everybody else wants to get off of those. However, I can't speak for the committee.
Everything is possible if you have a well-written proposal with good rationale.
The Iostream solution is an ATS solution. It is type-safe and extensible. What a lot of people want is a 70s solution that's type-unsafe and unextensible. We have to do better than both to make any progress.
I believe there is an active proposal, or soon will be, for FMT. I don't know its status, but I consider it better. That wasn't my question, though. My question is, what's so hard about standardizing atomic shared putter?
We're doing it. It's going through library wording review, and it's expected to come up for a plenary vote into C++20. Weren't you the same person who was just here? You're now later in your own queue, and it is very likely to be part of C++20 in the next meeting or two, unless something comes up. It was published as part of a concurrency TS first, so it seems to be on track.
So the answer was nothing? One word? for a very large value of 1.
But also it comes back to motivating use cases. It required convincing for people who were skeptical about the use cases.
Okay.
Let him go first. All right. Question.
Go ahead.
What the hell is a monad?
No.
What is a monad was the question. And this is the wrong committee.
It's
We do have
fuzzy
donation.
thing. A warm, fuzzy thing.
One fuzzy thing, yeah.
It's a monoid in the category of endofunctors. One sentence.
Very good.
I watched a video from the Guerrilla Committee from, I think it was last year or maybe the year before. It was pertaining to my field of, bare metal stuff and why everybody uses C. And the answer coming from the committee was mostly it's a marketing problem. And I agree with you on core language, like, in our build system, there are maybe 20 compiler flags turning off absolutely everything we can turn off. And then at that point, we are more efficient than C. So there's no problem there in my mind. But when it comes to libraries, do you still see it as only a marketing problem? Or have you used like interrupt service routines that interrupt a thread and use its stack and the implications of locks in that context and stuff?
Well, in C++, in Windows NT kernel, people use C++, but not the library
Yes.
part.
Yes.
So but there is SG14 group, which right now is looking into those things and trying to address those bare metal people.
It's a marketing problem because C doesn't have anything better either.
I agree.
Yeah, and if you look at the standard library, the STL part, for example, most of the algorithms are just fine with, bare metal. They don't require any extra runtime or any of those. So I've seen them used in practice. So I agree, it's a marketing and education problem.
Could I tie this back into Eric Niebler's response to my last question about level of abstraction? Because there is a certain level of trust that the person that wrote that level of abstraction in code and language that I cannot review because it's in a language, part of the language that I don't speak, that he was thinking about my problem and that the guarantees he's making for, desktop development will also hold in another context.
Yeah, I can speak to that. I've seen people very fearful of using stud sorts because they say, it is the STL stuff. And they were using bubble sorts. And I had to sit down with them and go through the code and convince them that if you just type stud sorts, you give the first argument, the second argument, it actually go much faster than the bubble sorts you just wrote yourself because you couldn't trust the standard library because it has higher abstraction level. This is from real world.
I think Titus wanted to be the next respondent.
You have to know how much to trust your librarians. They have to be clear about what they're actually providing and what they aren't. See my talk tomorrow.
Okay.
There's plenty of room for improvement in order to make the library more useful for the use cases you care about. But luckily, there are people working on that problem.
Okay, so we're now at 15 minutes, so we're going to stop the rule of 2 and 2, and we're going to draw the rule of 5. You have 5 words.
Oh, boy. All right, well, mine was going to be difficult to answer in 2 sentences, and also kind of a repeat of Odin's, because I know we've talked about this before. I didn't know he was going to ask that one, but it's kind of shaded into this one, which is, in C++, we have a very sort of core languagey way of expressing certain properties about behaviors, certain things like this function doesn't throw, and therefore things that call it don't throw, and that no except goes all the way up. Const experness can kind of be propagated now. Triviality can be propagated, but certain other things, pureness, non-memory allocation, non-touching globals, touching only thread local storage, not taking mutex locks, not doing disk I/O, many, many different things, which is kind of what Odin was saying, right? The high-level code has certain things it wants to know about the low-level code in the way that's going to use it. You said some people are working on this. Who is working on this, or what progress is being made in not necessarily taxonomizing and categorizing the different kinds of behaviors because they're infinite, but allowing the high-level code to ask these questions and the low-level code to make these guarantees? 5 words or less.
Try solving it with contracts.
Can you say that?
I simply don't accept the 5-word things because you can't give it a really decent, thoughtful answer to that, and it deserves an answer. First of all, we should not litter the language with a keyword and a property for everything anybody could possibly want. The language says what is possible and what it means. It doesn't say what you should do. In particular, it does not say what you should do in a particular subfield. I write a lot of code where calling malloc is a disaster. It must not happen. That should not be a language feature. This should be a guidelines feature. And what we need is a not-so-core guideline for, say, bare metal programming, for low latency programming, for programming where you are not allowed fragmentation and things like that.
Well, I think my problem with that is that in library code such as the STL, where, for example, you have to know that std sort is perfectly safe to use and std in place merge is not safe to use in exactly your use case, but they don't expose that in any way in the type system. Is it possible to do that?
Contracts, concepts, guidelines.
Save them for next time. All right, Nicole.
So first of all, the keyword, like the and or not keywords, I looked it up. It came from C95, which was kind of the internationalization of the C89 standard for international keyboards that may not have those specific characters on them.
It's not true. I did it before that.
That was the reasoning that the STI standard gave, anyways. So what was my question? There's something I've completely forgotten.
The C standard didn't always credit you. No, it doesn't. C never credits us. You can hear that comment. When C takes something, they never credit us, and they always adopt it in an incompatible fashion.
Yeah.
Okay. / maybe if anybody can understand that section of the standards.
Sorry. This is a little bit later, and it may be more interesting to do in 5 words, except for Herb, who gets 7 because he saved 2 the other time. All of you guys were, we were all introduced to all of you as being up here for being associated with a specific thing you do or a specific thing you're working on. So it'd be really great if in 5 words or less, people could talk about describe how that idea came around, like a eureka moment, or how you got associated with the things that you're not working on. Except for Herbie gets 7.
This may be a CppCast thing rather
There's
than a...
little more important now than simplicity.
To boldly go, this will not work.
Boost range plus boost iterator equals adapters.
Thank you.
Herb wouldn't let me decline.
Oh, so many things I could say about concepts, but I will decline. So.
Write state machines as imperative code.
Five words is also about fun.
Boost MPL, metaprogramming, lots of pain.
All right, cool.
So back to the thing I was talking about before. I would really like...
Restrict?
We may have to put a limit on the questioner as well. I don't know.
I would like decal type... Shoot. I want decal type lambda expressions. When decal type lambda expressions?
So I'm working on the fifth iteration of the wording. It's just it's been through EWG. It's just about getting the wording done. Actually, if there is core people in the room, please review the paper that's in the mailing list, because I want to be done in Albuquerque, hopefully.
So what happened to unified call syntax and how to resurrect it?
It got killed with people far more concerned with the past than the future. Maybe it'll come back. This is not a completely unified opinion by everybody.
Makes librarians' jobs hard.
So let me try to provide a less inflammatory response than Bjarne did. Why? Because it's my job. So there are major concerns about silent changes to what your code means.
Have you thought about extension methods
So
like in C#?
let me give you a general answer, because this is, and I'm not going to stick to 5 words, because it's an instructive example. The concern is that you're balancing compatibility, so not changing the meaning of old code, and also future usability. If we don't change the meaning of old code, we can't just make member, non-member be equal, because that would change the meaning of this call site to old code. It could suddenly call a better match that's the other thing, right? Therefore, and this is the key part, you have to have a fallback. Anytime you have compatibility, it involves a fallback in a language feature. So you're falling back, that gives you the backward compatibility. Anytime you have a fallback, it means you can in the future write code that compiles fine today, but if somebody writes a better match that hits the non-fallback case, could change the meaning of that future code. Now this is code that does not exist today. But this is where Titus and others are concerned about, yes, but now I'm writing code that doesn't exist today, which I could make change meaning. Now, some people feel that, well, they'll get over it. It's just like name hiding. It's exactly the same thing with name hiding in class hierarchy. And some people are more worried about it. They don't want more of that in the language, or they're concerned about it spreading further. But this is a fundamental tension. It's not just about unified call syntax. Backward compatibility, you often resort to a fallback to maintain backward compatibility, and then it creates a hiding situation where you can hide something by new code that didn't exist before in the new cases. Think that through just with an example or two and you'll see what I mean, but it's a very general problem, not just, it's about any compatible extensions.
Aren't we trying too hard? We should keep simple things simple, and there are languages that have solved this problem, and we should learn from them. And there are multiple...
Ask the Python folks how they like their bifurcation.
Just look at C# and other languages that have extension methods. It works.
C# hasn't been in existence for multiple decades, nor does it have existing code bases of multiple billions of lines of code. It's a different problem from their perspective.
I mean, we solved the compatibility problem. It is the question of whether you add another overload and whether that is acceptable.
Also, it's very important to learn from other languages, so the C# experience was cited in Bjarne's and my papers. We were the main authors of the Unified Function Call Syntax proposal. But it's also important to understand where they're different. C# doesn't have free functions. It's a different language. Their experience may inform what we do, or it may not. And so it's important to keep eyes very wide open and see what are the valid learnings and what are the invalid learnings, the MacGuffins that can actually lead you astray.
Oh. Thank you. Are metaclasses scheduled to be discussed by the committee? If so, when? Otherwise, why not?
There was an initial presentation for the very first time just 2 months ago. Very early days. This is going to go on for years before we know whether it pans out or not. So some said, oh, is this in C++20? Oh my goodness, we won't know if it works until then. So this is very long lead and experimental. The things in this area that will come sooner are reflection, compile time programming.
Yeah, we're going to keep pushing smaller parts of that through SG7, I think.
What?
Yes, SG7, slowly. Very, very slowly.
I can't do it.
Hi, so forgetting return statement is undefined behavior inherited from C. So why do we still have it in C++? Like why it is still undefined behavior if you forget a return statement in a function?
You're not initializing the return variable, return object.
Yeah, but you could define it as do not compile, right? The compilers are pretty good at finding those things and issuing a warning.
So this is actually something that the community takes very seriously. When we did ConsExpert, one thing we made sure was that if you either run into undefined behavior, it will be detected. The compiler is required to detect it and report it back to you. So the question is whether people have enough experience with that and feel comfortable and move that compile time guarantee to runtime. Right? So it's always a matter of getting experience, getting some familiarity to get into new territory.
What are your thoughts on a safe chain dereference operator? A safe chain dereference operator where you dereference, if it's null, it returns null.
That's an interesting idea, but I think Bjarne is going to call that Swift envy. I think it's potentially so useful an idea that it would be worth proposing it and discussing it. Whether that discussion will lead to actual language extensions is a very different matter.
Wow. We're there, and I guess the rule,
5 words. We do that with delete.
All right. I think it's been very educational. One of the things that we found is that some of the members on the committee can count to 2 or to 5. I want to thank the committee, the representative of the committee. So we'll see you all again tomorrow. I hope you're having a great conference.